tonight's med dosage live session, I'm going to pop a link up here, my med dosage playlist. Look at that link right there. I'm going to load that up real quick. And just like I have a tease live session playlist, I have a med dosage live session playlist. And what I've done in the past, I've done a mixed bag. I've done 6 live sessions so far, but number 6, the one I did about a month ago, I did just flow rates in milliliters per hour. Whereas the live session 5, 4, 3, 2, 1, these were random problems, kind of like all over the place. Now, before we get started, I do tutoring for all types of math. I have a med dosage workbook. It is very similar to the Tease Math workbook, except it's the med dosage workbook. Let me pull it up real quick. I want to show you a few things, because if you do have it, or even if you don't, or the med dosage online review, either one of them or both, they are 2 different things. So let me show you the med dosage workbook real quick. If you've used the Tease one, you'll be right at home with the med dosage workbook. So it's not just a workbook. You get video solutions with this as well that you cannot find on YouTube. So you have the workbook, you can download it, and then you have video solutions. And those video solutions come from what I call the power hours. Power hours are like what I'm doing now, except the power hours are live sessions that I do just for people who have the workbook. So not everybody can access it. And those are typically smaller classes. So sometimes I do unmute the microphone and we can talk back and forth. If I load up the med dosage workbook, it's very similar to the Tease workbook in terms of how you can navigate. So you can be anywhere in the workbook on any page. And if you want to get back to the table of contents, top right corner, tap on that. Boom, we're back at the table of contents. You have all of your sections, the most common types of problems you'll see, your basic conversions, weight-based, safe dosage, milliliters per hour, drops per minute, tonight's session. And then you have challenging, all that good stuff. But then once you go down to the second page of the table of contents, this is where you actually get your solutions. So if I just click randomly on one of these, let's suppose we're doing weight-based. You have the problem, you have the answer, you have a explanation, and then we also have the dimensional analysis. And that is how I teach med dosage. You know, I'm showing this to you all because, one, I want to show you how to navigate it if you get it. Because a lot of people are like, where are the answers? I don't know where the answers are. If you go to the table of contents, there's an entire solution section. And then 2, I want to point out, I teach med dosage using dimensional analysis. I'm not a fan. I'm a math teacher. I've been teaching for 15 years. I love showing different approaches, or over 15 years. But I love showing different approaches. But in my opinion, dimensional analysis is the way to go for med dosage. Sure, there's this ratio and proportion technique. There's the formulas approach. There's the desired over half. But those only work for certain problems. Desired over half can get real messy if you have to do a lot of conversions within your problem. And I've worked with enough students to know when you get to those more complex problems, you're going to get mixed up on what number goes, what number am I using, or do I convert this and that? If you practice dimensional analysis, I kid you not, every student that I've tutored, I've never had a student come to me that I've tutored and they said, hey, after I've worked with them, or even some who have watched the videos, that playlist, well, I haven't heard anybody say, hey, I've watched the videos and I still hate it. Especially when I've worked with people one-on-one. So I'm a fan of dimensional analysis. You don't have to memorize formulas. All you need to know is conversions. That's what's cool about dimensional analysis. It's not a formula. It's a technique. So that's why I use it. Sure, can you use desired over half for some of these problems? Yes, but it gets messy. And I'm not going to show you desired over half, because there is a problem tonight, and I think I even mentioned it. 3 problems, and one of these is really tough because it requires so many daggone conversions. And if you try desired over half or some formula approach, I think it's more trouble than what it's worth. The med dosage online review, this is different than the workbook. This is an online thing. So the free sample, you don't have to purchase anything. This is the free sample for you to try. The online review, you can read over that. There's that live session playlist again. And if you start, now you can work through these problems. They're all fill in the blank. And oh my goodness, look at that first one, a drops per minute problem. Who would have thunk? and you can check it and save it. And when you check it, you'll fill in the blank. It'll tell you what the correct answer is. And look at there. If you get used to dimensional analysis, you will get used to seeing how I do it. And I'm starting off with GTTs, and I'm just canceling out. Ironically, this first problem was a GTTs problem. Then the next one, this is a tablets. So try out that free sample, see how you like it. The QR codes, join the Facebook group if you're not in it, the email newsletter. This is where I send out updates once a week or every other week. I do tutoring for all types of math. So, snap those tonight if you want to. Check those out. By the way, both of these products, the workbook, the online review, both of them, they are not a time expiring thing. Once you get it, you always have access to it. I do still update these from time to time. They did receive a lot of updates over the past year, and I haven't updated it in a few months because it's pretty complete, both for T's and med dosage, but I still do add stuff, videos and whatnot, so it doesn't expire. Once you buy it, you have it. All right, so what we're going to do, we got 3 problems. They are going to get gradually more difficult. The third one we do tonight is going to be the tough one. What I'll do is I'll put a minute, let's do a minute 30 up here, and go ahead and give it a shot. Feel free to type in your answer. We're finding drops per minute. All right, so for our first problem, the correct answer is going to be 30 drops per minute. But if you're here, now desired over have and all that, I mean, formulas, yes, but different formulas work with different problems. I'm still going to stick to dimensional analysis. And for dimensional analysis, I say this in every single live session that I've done. I always ask the student, what are we trying to find? We're trying to find the drip rate. We're trying to find drops per minute. And I like to go ahead and write that down. Our answer needs to be drops per minute. And here's what's cool about dimensional analysis and med dosage. Go ahead and look for that. I could care less, honestly, to start off with, I could care less what the problem said. I'm looking, when I do med dosage problems, I go ahead and look, what am I trying to find? We're trying to find drops per minute. So now that I've established the goal, I know what the question is asking. Drops per minute, I focus on that top word, GTT. GTT, that's what I'm going to start off my problem with. Now, how do we do that? Well, up here, 120 milliliters per hour, that's not helping me. Boom. 15 drops per milliliter. This is called your drop factor. So there's 15 drops of this liquid that equals 1 milliliter. That's really what that means. Now, the way I'm going to write it, since GTT is at the top of our goal, I'm going to put 15 drops at the top, and I'm going to put milliliter at the bottom. I'm using that right there. Now, let's put on the brakes. Let's talk about this. We've already met the first part of our goal, GTT. That's our top word. But we don't want the word milliliter. We need to get rid of the word milliliter. And this is dimensional analysis. Why do we not want milliliter? Because we want minutes. We want drops per minute. We don't want drops per milliliter. Well, to get rid of milliliter, I'm not even going to read the problem. I'm not going to read the problem anymore. Automatically, we need to get rid of this word. And to get rid of that word, we're going to multiply and we're going to create another fraction. And since we want to get rid of milliliter, and this is at the bottom, put the word milliliter at the top of the next fraction. This is how you get rid of words. We got milliliter at the bottom. We got milliliter at the top. This is how we cross words out. Now, we do need to look back at our problem and find something that we know about milliliters. And the infusion rate or the flow rate is 120 milliliters per hour. Now let's put the brakes on. If you stopped right here, your answer would not be correct. If you stopped right here, you would have GTTs per hour, but we don't want GTTs per hour. We want GTTs per minute. So therefore, how do we get rid of this word hour? Well, just like we got rid of milliliters, bottom and top, we're going to do the same thing with hours. I'm going to put hours at the top, and this is where you need to know your conversions. Yes, this is a conversion. 1 hour is equal to 60 minutes. That is a conversion, isn't it? Just like 2.2 pounds is 1 kilogram, or 1,000 milligrams is 1 gram. These are conversions, and this is useful. Why? 1, you get rid of hours. And 2, look at what you've done. We have the word minute. Magically, it almost feels like magic. It just flows so nicely, no pun intended. The way dimensional analysis works, it has a nice flow to it, the way you get rid of words, and it just works itself out to where you end up with the right words at the bottom. We start off with the top word, GTT, and we're going to do this for every problem tonight. We start off with GTTs at the top, and we're going to have to flow through this thing to where we can eventually get the word minutes at the bottom. And a lot of times you'll use this conversion. So now that we've met our goal, we got drops, we got minutes. Now I'm going to touch the calculator. Haven't touched the calculator all night. So here's how you do it. You multiply all of your top numbers and you divide by all of your bottom numbers. But something to point out here, like this 1, multiplying. If we multiply all these top numbers, multiplying by 1, you don't need to do it. You're wasting your time. You can if you want, but think about it, y'all. Multiplying by 1 don't change a daggone thing. And this right here, this is 15 drops per 1 milliliter, 120 milliliters per 1 hour. These ones are not important at the bottom when it comes to calculating. So really the only things you need to be multiplying are the 15 times 20, multiply your, 15 times 120, multiply your top numbers. You don't have to press equals. Immediately divide by, and the only number we have to divide by is this bottom number 60. And when we do that, this is our answer. Again, you're going to hear me say this over and over and over and over. Multiply your top numbers, divide by your bottom numbers. This will always work. I don't care if you're doing drops per minute, milliliters per hour, milligrams per day, tablets per dose, whatever. This technique always works. So 30 drops per minute is the answer for our first one. Now we're going to bump up the difficulty level a little bit. Number 2 is going to be a little bit tougher than number 1. Minute and a half, try it out. So how many drops per minute? This is our goal. I always like to establish that goal. This tells you how to start off your problem, and it tells you ultimately what you need to have, what words you need to have. So we need drops per minute. And just like in the first problem and every problem tonight, we're going to start off with GTTs in our first fraction. This always works. Always look and see. Start off. I mean, yes, there are other ways to do this. There are other ways to do dimensional analysis. But I'm telling you, if you start off with that top word, whatever it is, you're off to a great start. All right. What do we know about GTTs? 30 GTTs per milliliter. So 30 drops per 1 milliliter. So we've used that. We're already off to a great start. We got GTTs. Now, when you get rid of milliliters, y'all, so automatically, I'm not reading my problem. I'm automatically going to put the word milliliters at the top of my next fraction because I need to get rid of that. Well, if we look up here in our problem, milliliters is not mentioned, but we do see liters. Guess what we need to do? Let's not do any, I mean, you can do the conversion outside of your dimensional analysis if you want, but things can get messy sometimes. So instead of me doing the conversion outside of the dimensional analysis, I'm going to do the conversion in the dimensional analysis. There are 1,000 milliliters in 1 liter. Why did I use this conversion? Why do we use conversions? There's 2 reasons, well, 2 reasons in most cases. One reason that we use conversions is to get rid of a word that we don't want. Boom, we're getting rid of milliliters. And the second reason we use conversions is so that we can bring in something from our problem that we can use. So that 1.25 liters is going to go at the top of this next fraction so that we can cancel out the word liters. And that's the thing that can be a little bit challenging, is like, how do I know when to use a conversion? And it comes with practice, y'all. But you use conversions to get rid of words that you don't want, but yet you need to bring in another word. We had to bring in liters because we didn't, we had to get rid of milliliters, but yet milliliters was not up here. So we had to convert to something that was. This is why we do conversions. Now, what about this 1.25 liters? The 1.25 liters is going to run for 12 hours. Now, if you stopped here, you got that same problem, y'all. You would have drops per hour, but we want drops per minute. So guess what we're going to do? We're going to use another conversion, and we've already used this conversion once tonight. We're going to do 1 hour over 60 minutes. I'm not doing any calculating. I have not touched a calculator yet for this problem. I don't touch the calculator in dimensional analysis until I've met my goal. I do not touch the calculator at all until I've met my goal. I'm not doing any math until I've got, in this case, for every problem tonight, I want drops to be the word at the top, which it is, and I want minutes to be that only word at the bottom. Only when I have done that is when I'll go over here and touch my calculator. So let's multiply our top numbers. What numbers do we have to multiply up top? We got a 30, we got 1,000, and we got 1.25. So 30 times 1,000 times 1.25. You can press equals if you want. I don't. I immediately start dividing. Notice I'm pressing divide. We have a 12. Notice I'm skipping the 1 milliliter, the 1 here. But we do have a 12. So we're dividing by 12. Don't press equals. Press divide again because there's another number at the bottom, 60. So we're going to divide by 60. And this is the answer that we're getting. We're getting 52 point blah, blah, blah. And we want to round this to the nearest whole number. And 52.08 is still just going to be 52. So 52 drops per minute. Why was this one a little bit tougher or longer? Because we had to do two conversions. Now, if this is your first time doing dimensional analysis, if you're starting to kind of get an idea, good. I mean, don't expect to be able to sit through 30 minutes. I mean, some people can, but most people can't. I mean, I know when I'm learning new things, I'm not going to master something in 30 minutes. It does take practice. It does take a commitment, but think of it, I mean, this may sound crazy, but think of it like a hobby. Or think of it like a sport, basketball, shooting free throws. I'm not a great basketball player, but I like to think I'm pretty decent at shooting free throws, but I have shot a bunch of free throws. Same thing with math. You practice it and you get better at it. And when you start getting these problems right, I mean, you may be surprised, but you might find this kind of fun. It's rewarding to get these problems right. And we're doing the same technique over and over and over, dimensional analysis. So, a little bit tougher because it required two conversions. And here is the tough one. And the reason why it's going to be tough, one, it's going to require a lot of conversions. And two, we got this weight based, which I do have some live session problems already on that playlist involving weight. But this is a tough one. It requires a lot of different things going on. Dimensional analysis, I will give you let's do 2 minutes and 30 seconds. Try it out. All right, so here we go. Last problem for the night. And for this one, it's the same. So, we're focusing on GTTs per minute. So let's establish that goal. You don't even have to don't even read the word problem itself. I'm telling you, this is like one of the few times in math where I tell people, hey, look and see what the question's asking you to find. And the question is asking us to find how many drops per minute. So it's that same goal. And if you establish this routine, it's not always going to be drops per minute. You know, the live session number 6 that I did, that was milliliters per hour. But it can be tablets per day. It could be capsules per dose, whatever. But you establish this routine. Let's start off with drops. What do we know about drops in our problem? We have micro drip tubing, and micro drip tubing, there's our GTTs. So I'm starting off with that top word. And again, that's the same thing every time I do dimensional analysis. That word, whatever that word is, 60 drops per milliliter. So we're already off to a good start there. Now, for the next thing, we need to get rid of milliliters. So I'm not looking at the problem. I'm not looking up there. I know I need to get rid of milliliters. That's what I'm focusing on. So to get rid of milliliters, if we look at our problem up here, the actual paragraph, there's nothing there, but we also have this label. Now you may say, well, which one of these do I use? And I got a newsflash here. It doesn't matter. They're the same. On drug labels, they'll typically have like 2 different things up here, but they're really the same. And let me go ahead and point out, let me go get sidetracked here, but this is beneficial. If I put 200 milligrams per 20 milliliters, 200 milligrams per 20 milliliters. And I'll tell you what, I'm going to slide this over just a hair. Let me make a little bit of room here. Well, y'all, look at this. If we take 200 milligrams, I'm doing this top one here. If we take 200 divided by 20, let's do that. 200 divided by 20 is 10. Well, guess what? That means 10 milligrams per 1 milliliter. Do y'all see how it's the same thing? 200 milligrams in 20 milliliters of liquid is the same thing as 10 milligrams per 1 milliliter. My point here is this. It doesn't matter which one of these you use. I'm just going to use this one. Why? I don't know. Because I want to. But what this means is don't put the 10. Oh no, don't put the 10 up there. Why not? Remember, we want milliliters at the top. So 10 milligrams per 1 milliliter. Yes, that understood 1 needs to go up there, and the 10 milligrams needs to go at the bottom. But again, I would challenge you tonight, after we're done, go back and try it with this one. I promise you'll get the same answer. I promise. But what have we done here? We've gotten rid of milliliters. Now let's get rid of milligrams. Now, do not go back and use this again now. Don't use that again. So let's look at our paragraph. Do y'all see anything talking about milligrams up here? We don't. But we see micrograms. So guess what we got to do? Conversion. Because we can convert. One milligram is equivalent or the same thing as 1,000 micrograms. Why did I do this conversion? This is important to understand. We did this conversion so that we could get rid of a word that we don't want. Boom. And it allows us to bring in something from our problem. Now, this is a tricky part if you're not familiar with weight-based. I do have videos on this, and you'll hear me refer to this as what I call the double slash. 150 micrograms per kilogram per minute. The way I handle the double slash, I'm going to put the 150 micrograms at the top. Now, why did I do that? Micrograms, see you later. They cancel out. But these other 2 words in the double slash, we have a double slash, slash kilogram, slash minute. Those 2 words, I put them together at the bottom. Now, I am putting a little time symbol there. You don't have to do that. They are both at the bottom, but they are 2 separate words. So we still got to focus. It's still 2 different words. Now, y'all, let's put the brakes on real quick. GTTs, we're good. We got GTTs at the top. Now look, technically we have minutes at the bottom, and you may think, oh, okay, good. We've met our goal. Be careful. we want to find GTTs per minute. This means that those need to be the only two words. We only want GTTs at the top, and we only want minutes at the bottom, and we don't have that yet. We got to get rid of kilograms, y'all. We got to get rid of kilograms. So let's do that. Now, to get rid of kilograms, we're going to essentially do the same thing to get rid of words. Automatically, I'm going to put kilograms at the top of my next fraction because this will allow us to cancel out kilograms. And if we look back at our problem, I don't see kilograms getting mentioned anywhere except for right there. However, don't we see pounds? So guess what? We're going to do another conversion. And what is that conversion? 1 kilogram is equal to 2.2 pounds. I'm not writing down 180 pounds yet. No, we have to convert. Let's convert kilograms to pounds, which we've done here. And now, absolutely, we can definitely come in here and bring in this 180 pound patient. So 180 pounds, that goes at the top so that you can cancel out the pounds. Same flow. And what are we going to put this over? It's an understood 1. And what that 1 represents is the 1 patient. And I'm writing it down here. You don't have to include that word. I'm only writing it here to help you understand what that 1 represents. It represents the 1 patient. But now let's step back. What's the only word we have left at the top? The word we started off with, GTTs. So we've met that goal. And again, ignore the word patient. You don't want to write that word in your dimensional analysis. That's what that 1 stands for. But if you look across the bottom, the only word we have left at the bottom is the word minutes, and that's what we want. So now we have officially met our goal. Now we are ready to multiply and divide. And look at how long this is. This is why this is a tough one. So let's multiply our top numbers. Let's look and see. 60, a 150, and a 180. I'm skipping all of the ones. So 60 times 150 times 180. I don't press equals. I immediately start dividing, and we're going to have to divide by 10. We're going to have to divide by 1,000, and we're going to have to divide by 2.2. So I'm going to say divide 10, divide 1,000, divide 2.2, and now I'm going to press equals 1 time. And if you look at this number, drops per minute, we round this to the nearest whole number. So therefore, from this 73.6, we would say this rounds off to be 74 drops per minute. Now, if you tried to do desired over have or some ratio, proportion, or formula approach, and they can get a little bit longer than this too, y'all. Like imagine if this minutes here had been hours, then you'd have to convert that. In this case, we didn't, but they can get longer. Dimensional analysis, I know it looks long, but it has a flow. You're getting rid of words. You're trying to meet some goal. And when you have met that goal, that's when you go and start banging on that calculator to get that answer. Same thing every time. I hope you found all this helpful. I appreciate you all attending, and join the email list. That QR code is on the notes. Join the email list to stay in the loop. Join the Facebook group. I do constant updates, announcements of when I'm holding these sessions or when there's sales or when there's new videos and all that good stuff. So thank you all for attending. I will see you all in the group or wherever it may be. Take care and good night.